Tonight's lecture on 5G spectrum is being presented by Abaya. He's not only is he the current chair of the Berkshire Local Network, he's amassed over 20 years experience and has helped a wide range of international companies, regulators and governments. Previously, Abaya led and delivered multi-million-pound strategic network capacity programs at 3 UK. Currently, he leads the spectrum and regulatory practice at realwireless, and he has recently led teams to deliver programs on spectrum valuation for auctions, very topical for tonight's lecture, techno-economic and business case analysis for 5G use cases, 5G spectrum benefit assessment and developing future telecom strategy for mobile network operators, regulators and governments. He is also the Deputy Chair of the UK Spectrum Forum Policy Steering Board. So without further ado, I will hand over to Abaya.
Thank you, Keith. Hello, everyone. I'm delighted to welcome you for today's event on spectrum valuation and 5G. So let's talk about value of spectrum in 5G world. So, as Keith mentioned, in the past, I had the pleasure of working for mobile network operators as well as regulators. So I had the opportunity to understand the narrative from both sides. Now, since I joined realwireless about 7 years ago, I've been leading the spectrum and regulatory practice. So realwireless is an independent expert wireless advisory firm. We work closely with wireless industry side and wireless user side. That includes mobile network operators and regulators and many other wireless companies. So that gives us a good opportunity to understand these problems from what they face, as well as we work very closely with them. So particularly with about the auctions and supporting that. So in realwireless, our practice actually, we do many things like policy development, cost analysis, coverage obligations, and today's topic, spectrum valuation, is something that we again work closely with many regulators. Therefore, we are well placed to comment on this topic. Onto the agenda. First, I'll explain about the value of the spectrum. Why do we have to understand the value of spectrum? And today's focus is about the mobile networks. So the characteristics of mobile networks. And then talking about the value of spectrum, I'll explain the factors affecting the value of spectrum and provide a explanation of some methodologies used by the mobile operators and the regulators to value the spectrum, and finally about the 5G and its influence. So we have time to question and answers at the end of the day. So if you have any questions, please keep typing on the Q&A section of the Zoom platform. Okay, so just a brief introduction to spectrum. As we know, spectrum is the lifeblood of the wireless world. So any wireless operator requires spectrum. The spectrum, electromagnetic spectrum, is actually a very wide. However, the portion of this spectrum, electromagnetic spectrum, that is desirable for radio transmission, we call that as radio spectrum. And you can see within the wide range of spectrum, the usage is concentrated in certain portion of the spectrum, particularly in the past, this 300 megahertz to 3 gigahertz portion. You can see most commonly used services that we use every day: radio, TV and mobile services. We call that at the sweet spot because that part of the spectrum has special characteristics, propagation characteristics, helps radio transmission. And the good thing about the spectrum is, unlike other natural resources, it never wears out. In fact, we can repurpose. What it means by that is the spectrum we use for 3G and 4G mobile services, some of the spectrum is the same spectrum that we used for 2G services. And we clear that spectrum from 2G and 3G. Now, operators in the UK already started switching off their or scaling down their 3G networks. That is because they can repurpose that spectrum and use that same spectrum for 4G and probably 5G services. So the problem with many users concentrating in a small portion of the spectrum is that it's potentially there can be interference from different services. And that is why we need to manage the spectrum carefully. And that is the job of the national regulator. So when we talk about spectrum, it's important to understand this, how the regulators view this spectrum. Obviously, spectrum is a scarce resource, and for most of the spectrum bands, the demand exceeds the supply. Now, what happens is most of these services that we talk, we are commonly, we know that we use every day, the services we use every day, like mobile service or our TV service, radio service, and the satellite services, some very much widely used as well. And all those services, they predict their usage increase. We know very well the mobile service, the demand for mobile services increase. Therefore, equally, the demand for spectrum increases as well. Now, then there's a question for the challenge for the regulator. How do we prioritize? How do we allocate spectrum? And that needs a trade-off, consider trade-off between different potential users. Now, because the demand is very high for some services, of course, the mobile is a good example. Regulators assign spectrum via market-based approaches. Good example for that is auction. So where a bidding takes place and the highest bidder is awarded the spectrum. Now there's a 5G spectrum auction is actually around the corner. Ofcom announced that it will probably start early next year. So this is an interesting time for operators because everybody is preparing for this auction. In fact, I'm sure all operators have already prepared because it was supposed to happen a few months ago, and due to COVID problems, it was postponed. Now, therefore, when we think about the regulator, their objectives, usually regulators are independent, like Ofcom. Their objectives are set by the parliament. So their key objectives are secure the optimal use of radio spectrum, and also maximizes the value generated for the society. Now, that's an important thing. Regulators don't prefer any technology, therefore, we call it a technology neutral approach when they give spectrum to assign spectrum, and also not a specific company. So therefore, they are trying to be neutral, and they are trying to maximize the value generated to the society. Now, from the regulator's point of view, therefore, is important to understand the value of spectrum so that they can maximize the value to the society. So today's focus is about mobile networks, and let's think about how mobile network operators see the spectrum. Now, the characteristics of networks. as we know, the demand for mobile services continue to increase, but demand for particularly data services. And another important issue to note is that this demand is actually not uniform across the area. This is a map published by Ofcom some time ago. You can see major cities have like London and Birmingham, Manchester has high demand compared to other parts of the country. So you can see this, therefore, the demand is not uniform. And I'll come back to, in fact, the point is about 20% of the data traffic is actually generated within 1% of the UK geography. So, so that nature of non-uniform nature of the demand plays an interesting role when operators deploy the mobile networks. So that's the demand side. And in order to serve this demand, mobile network operators have to deploy additional capacity, increase the capacity of their networks. So there are three options. There are various solutions available, and three main options available is, firstly, enhance the technology. So that is, the technology in fact carries bits over the air. So we measure that efficiency as spectrum efficiency. So for example, the 4G services are much more efficient compared to 3G services and 2G services. 5G is even more efficient. What we mean by efficient is that for the same amount of bandwidth, using the same amount of spectrum, an efficient technology can carry more data. Therefore, they are spectrally efficient. So it's obvious then to make the efficient use of spectrum, we try to deploy new latest technologies. Now, when we do that, obviously there are some limitations. Firstly, the cost. New technologies will cost, and also they're not available immediately. They take, for example, some time to mature. We are only seeing 5G technology being standardized, advanced version we call release 16 is standardized only recently. Therefore, it will take usually 1.5 years before, once it's standardized, before the equipment is available and widely available. So there's a limit how fast you can upgrade the technology. And also you can only benefit from the advanced technologies when the users have the handsets that are capable of supporting these advanced technologies. For example, even if we deploy 5G today, because all users don't have 5G capable handsets, the benefits are still limited. So that is the first solution available for mobile operators, upgrading technology, and it has their own limitations. The second solution is you can upgrade the infrastructure. In other words, you can deploy new sites, more sites. So when we talk about 5G, adding new sites or small sites is something probably begin to take off. But again, the deploying new sites also has their own challenges. Biggest challenge is the cost. Deploying a new site, usually a macro cell site usually cost about 100,000 or more pounds in the UK, and it takes time. So therefore, that's a huge expense. And just imagine how much it will cost today's operators. Usually in the UK operator, on average, they have about 16,000 to 18,000 sites per operator. So obviously they have some site sharing arrangements, but the cost of deploying sites is, again, that's a second solution, very expensive. The third option operators have is to deploy additional spectrum we call carrier upgrade. Now that upgrading a carrier is usually about, if you compare, 10 times less expensive compared to deploying a site. So the carrier upgrades is, obviously there are some specific challenges, how many carriers you can deploy on a given site, but upgrading carrier probably 10,000 to 20,000 pounds compared to deploying a site at cost of 100,000 or 150,000. So that's a very economic way of adding capacity into the network. That is why operators are really trying to acquire as much spectrum as possible. Now you can see on this side of the slide the spectrum holdings of the UK operators as of today. They all have their different amount of spectrum, and they have different market shares as well. So in summary, spectrum oriented capacity supply, or supplying additional capacity using spectrum, is much more economical compared to densification or deploying more sites. Now, this is why operators try to acquire a spectrum, and it's one of their objectives. So additional spectrum also gives other significant benefits to operators. For example, we talked about getting a greater economic value from the existing sites, and also it gives more capacity. Then you can also have better service quality, because additional spectrum, more spectrum, can deliver faster data rates and higher quality. It also help you increase your coverage depth. For example, lower frequency bands, their propagation characteristics helps penetrating deeper into the building, so you get in-building coverage, and the cell range is much higher compared to higher spectrum. So there's another advantage. It also helps operators to enhance their strategic value and defensive value. Sometimes when you want to deploy new services, last thing you want to worry is that if it's very popular, network gets congested, so users get bad experience. So you have to make sure you have enough capacity, you can provide enough capacity when it needs, and that gives a very upper hand to operator who has a higher amount of spectrum. When we talk about spectrum, it's actually important to consider not a specific individual band, and also basically the whole spectrum portfolio operator has, because each spectrum band has its own role to play in the network. For example, sub 1 gigahertz propagates longer, cell range is larger, and higher band spectrum has higher bandwidths, therefore higher capacity. So therefore, it's important to identify that whole value of the whole spectrum portfolio, and also it enables operators to leverage their strength and deploy new revenue, deploy new additional capacity, and get new revenue opportunities. So it's important also to acquire the spectrum at the right price. Now you can see this is a chart, the Vodafone's share price taken from Google as a source. When we had the 3G auction in around 2000, the share prices were very high. It was actually there's more other factors involved in that, not just this. But subsequent auctions, share prices didn't really change much. So this tells the correlation between the share prices and spectrum, the enterprise value, in fact. there's less correlation over the recent years. Nevertheless, there's some operators consider as a strength having more spectrum. So when we try to talk about, to understand the value of spectrum, it's the key point we need to know is the value of spectrum is actually derived from the demand for services delivered using that spectrum. So just take mobile as an example. The mobile demand is very high, demand for mobile services. And therefore, the value of mobile spectrum is very high as a result. Now, we usually use models to estimate the value of spectrum. And there are different methodologies, but the important thing is the valuation has to be clear, transparent, and it has to have follow logical steps and scientific. So you have to get the value in the right range. You don't have to get the exact value because it's very difficult to predict the exact value of spectrum. There are many variables, but as long as you are in the right range, that's what matters. In an auction, for example, if the estimation is low, it could result in not acquiring spectrum. For example, you value the spectrum low, and on the other hand, if you value very high, you might end up overpaying. So that either way, it's not good. So therefore, you have to get the value in the right range. The value also subjective. As I explained, the regulator aims to maximize the value generated for the society. On the other hand, mobile network operators aim to expand services, increase revenue, and also the shareholder value. There could be some correlated objectives, but there are some differences as well. Then the value also has different interpretations. For example, private value means the prices paid by the users to service providers. We pay to operators and have a mobile service. So that's a private value. And on the other hand, social value, the regulators usually consider a broader social value that's benefit to society. And for example, when you deploy new technology generation, there could be additional jobs, and these are the things that can help the society. So value therefore has different interpretations as well. Now let's see the factors affects the value of spectrum. So firstly, bandwidth. The amount of bandwidth, the more you have, the better, higher capacity you can provide. However, from the economic point of view, demand, when you have abundance of spectrum available, the value could decrease. Then the existing spectrum you have, for example, if you don't have the mobile network operator, doesn't have the sub-1 gigahertz spectrum that helps them achieve higher coverage targets, then their value for spectrum, sub-1 gigahertz spectrum, is very high. They really want sub-1 gigahertz. So therefore, depending on your existing spectrum portfolio, the way you value a particular spectrum band could be different. The interference spectrum, usually mobile spectrum, regulator make sure that they don't have any harmful interference, so that the operators can operate their services or networks interference free. There are different characteristics of different bands. As I mentioned, some bands have more suited for coverage. Some bands have has high bandwidths and more suited for providing capacity. So the characteristics of the spectrum band matters as well. And again, the device availability and market penetration. So If you think about 4G, 800 and 2.6 gigahertz band are the most popular bands. Means many network equipment manufacturers and operators deployed network, and wider range of devices are available. When you talk about 5G, as I found, 3.5 gigahertz is one of the most popular bands so far from the device availability point of view. Now, the external factors, what I mean by external factors is, for example, things that you don't have control. So harmonization, when we talk about spectrum, it's really important to consider harmonization. That is why usually regulators work within the regions. When you have harmonized, when the spectrum is harmonized, that means the many countries use the same spectrum for same service. So you can, firstly, you can, when you go to a different country, you can use the same mobile phone because the same spectrum is being used in both countries. But the biggest benefit comes from the economies of scale, wider market share. The equipment manufacturers now have a wider market share because the same spectrum is being used for the same service, and that will bring the cost down based on the unit cost, based on the economies of scale. Then time of release, it's important as well. When the operator really needs spectrum, you have to increase the capacity in the network, you have to do something. And if the spectrum is not available, they have to deploy additional site at a cost, or deploy new technologies. And if you do that, the spectrum requirement might reduce. So the time of release is also important. Competition, obviously, who else might want the spectrum? It changes the value. Then other factors like other spectrums are likely to be available in the near future. Restrictions, then some spectrum bands, coverage, there are coverage obligations, regulators attach coverage obligations that will usually reduce the value of that particular spectrum lot, we call. And also sometimes sharing or coordination requirements, those things will reduce the value. Then amount paid by the other operators in other countries. Also, the reserve price during the auction also changes the value of the spectrum. So when it comes to estimating the value of spectrum, one methodology used by, widely used by the industry regulators and operators is avoided cost modeling. The principle of avoided cost modeling is basically the value of that additional spectrum to the operator is approximately equal to cost savings possible from this additional spectrum. As I mentioned, spectrum allows operators to add additional capacity. If you don't have that spectrum, operator has to deploy new sites at a high cost. And if you have spectrum, you can avoid that deploying new sites or avoid upgrading new technologies. There may be other reasons to do that, but just for the capacity purpose, you can avoid or you can delay. And that much, therefore, that will help operators to save some cost. And that is the principle behind avoid cost modeling. So it's an international accepted methodology based on sound engineering principles. Usually when we consider avoided cost modeling, we consider a long-term view, 10 or 20 years rather than short-term. That, of course, it has some limitations. It has, it's sensitive to some specific parameters, which I will come to later in the presentation. So avoided cost usually provides a reliable lower bound. What I mean by that is Remember, I mentioned about other benefits of operators because of spectrum, better services, better service quality, then attract investments. All those things are very difficult to put a dollar sign or pound sign against that. They are speculative and they're subjective. It depends on the operator's strategy. However, the number of sites you need to deploy given a spectrum portfolio or the technology mix you have, number of additional sites you need to deploy in the network to serve the demand is clear. It's we can easily quantify that. So that is why usually we consider the avoided cost as a reliable lower bound. And so how do we do that? So this is, there are 5 basic steps. All you have to do is, in simple terms, this is you predict the traffic. For example, over the next 10 years, what is your demand? How does it increase? And then calculate the number of sites, number of additional sites required to meet the capacity demand, or it might be just upgrading the carriers on existing sites. So calculate the cost of upgrading the capacity, upgrading or deploying new sites. And also sometimes you operators have to expand the coverage. So you have to deploy again new sites in rural areas. So to calculate the number of sites required to expand the coverage. So you take, considering both of these requirements, consider and calculate or estimate the number of additional sites required to meet the coverage and capacity demand. Now, you know how much a site would cost, and therefore from that unit cost, you can calculate the cost of deployment, and from that you can calculate the avoided cost. I'll take you through again in a little bit more detail. So this is how we do that. So firstly, you have to predict the capacity demand for 10, 15 years, and also the coverage targets that are required because of a coverage obligation, or also. So you have to know how much coverage you will need by when, and how much capacity you need in each year. So of course, you can deploy additional, upgrade your technologies. And as I mentioned, it has some limitations, but you can use that when the spectrum or the technology is available, you can upgrade. You can deploy new sites, or you can upgrade those existing sites with additional carriers. And these considering the existing carriers or spectrum you have. So when you do that, you can calculate the number of sites, additional sites, or number of upgrades required to meet this capacity and coverage demand, multiply by that the unit cost, and that way you can get the cost of meeting the coverage and capacity target. So that is the cost of meeting the capacity and coverage target over the next 10, 15 years. That's we call the baseline cost. And then you have now additional spectrum. Consider a small portion of additional spectrum. Now your spectrum portfolio has increased. Therefore, you wouldn't have to deploy as many sites as you needed in the baseline case. Now, with this additional spectrum, you can calculate the number of sites, new sites, and number of upgrades needed to meet this capacity and coverage demand. You can again multiply with the unit cost of a site, and then you can calculate the cost of meeting the coverage and capacity with the additional spectrum. So the avoided cost is simply the difference. When we do this, for example, here, what we do is, this is an example existing spectrum portfolio. And when we do this, we usually do for different amount of spectrum. So firstly, you do this, calculate this whole thing, avoided cost, with additional spectrum of 2 by 5 megahertz. So that's the we calculated the baseline cost without additional spectrum, and now with 2 by 5 megahertz, let's say your cost is T, and then you do that again by considering 2 by 10 megahertz or 10 megahertz of additional spectrum, and that cost is another value. So on, you calculate for different amount of spectrum, and then with that you can calculate the avoided cost values for different amount of spectrum. So this shows actually a case study, a specific project we carried for a tier 1 mobile operator in Africa. And so for that particular operator, when we calculated using sub 1 gigahertz spectrum, additional sub 1 gigahertz spectrum for different amount of spectrum, you can see clearly when you have 2 by 5 megahertz of additional spectrum, your avoided cost is so much. But when you have 2 by 10, the avoided cost is actually more than doubled. So this is the benefit or the savings you get. So you can save much more when you have 2 by 10 megahertz. So for this particular case, that because that operator has didn't have enough sub 1 gigahertz spectrum, and 5 megahertz of spectrum is not enough to meet the demand, and but 10 megahertz spectrum is really makes a difference. So their value for 10 megahertz is really high in this case. And as you can see, when you introduce incremental spectrum from 2 by 10 to 2 by 15, the incremental benefit is actually much smaller compared to 5 to 10. So this is a good example of an operator who doesn't have enough sub 1 gigahertz spectrum and who doesn't and value that sub 1 gigahertz spectrum very highly. So when we do that for other spectrum bands, for example, low band spectrum, here the low band spectrum refers to 21 megahertz, 2100 megahertz band, which is commonly used 3G band, and 2.6 gigahertz band. So the cost savings is actually slightly lower compared to sub 1 gigahertz. Again, that operator, this particular operator, values sub 1 gigahertz spectrum highly. Of course, when you do, we also did for 3.5 gigahertz band, and it comes even lower. And what I was going to say, of course, this depends on the operator's existing spectrum portfolio. You can now understand why the existing spectrum, how existing spectrum plays a role in valuing future spectrum. And I mentioned that this is also quite sensitive to the traffic traffic level. So for example, if you have high amount of traffic, so we did this for low, medium, and high traffic cases, the cost savings are significantly high, because to meet that very high traffic demand, you have to deploy a large number of sites, and that many sites you can save if you have additional spectrum. So that is why the cost savings is much higher for high traffic. So that's kind of summary of the avoided cost and the methodology. Now let's see the influence on 5G. I'm not planning to explain too much about 5G, but all I will say is 5G is a unified and more capable platform that connects and drives deployments of, it allows operators to deploy very services with very different requirements. Okay, the most commonly used 5G bands are in here. So, for example, 700 megahertz spectrum, just as I said, sub 1 gigahertz spectrum has much lower bandwidth. It's about 30 megahertz or 55 megahertz, if I say. Then 3.5 gigahertz band is the most widely used or popular band to deploy 5G. The countries that have deployed 5G so far, Korea, Japan, China, all used hundreds of thousand sites, and using 3.5 gigahertz band. And also the 26 gigahertz band, very high, but that is another band which the industry considers for 5G. In fact, it is a globally harmonized band as of last WRC, which is the radio conference that decides about the spectrum allocation. So other points I would like to briefly mention is that the influences or key features that the NRU feature. So NR means new radio, which is another term for 5G. NRU is unlicensed. So make use of the unlicensed band with the mobile spectrum independently or with existing mobile spectrum. So operators in the future will be able to use, when we say unlicensed, in simple terms, the Wi-Fi spectrum, the spectrum that we use Wi-Fi for Wi-Fi. So operators can use that spectrum in addition to their own spectrum to serve the users. So this graph shows the value spectrum auction results. So as I said, most of these spectrum bands are auctioned, and some of the results you can see it varies significantly due to many factors, but Italy has a very surprisingly high auction value. The sold spectrum for very high value, but you can see it varies across. It has many reasons, which I'm not going to go into detail now, but just to give you an idea. So other international trends emerging with 5G, don't forget, these are not specific 5G features, or they can be in fact very independent from 5G, but they are now emerging as new trends. Local access spectrum, so which is short-term temporary spectrum for a local area like factory or port. So in the UK, Ofcom made this spectrum, small spectrum, about 3 megahertz in 1800 and 10 megahertz in 2300 megahertz band, and 3.8 to 4.2, as well as 26 gigahertz band. That's only for indoor deployment, 26 gigahertz, only for indoor deployment, but other bands for outdoor deployments and available through local licenses. Similarly, Germany has made 100 megahertz available for that. Finland as well in 2.3 and 26 gigahertz bands. Sweden, Hong Kong thinking the same line. So that's about the local spectrum, new trend, and also shared spectrum. So this is another interesting step taken by Ofcom recently, allowing operators to share their own existing spectrum with other users. Remember when I showed this map, you saw how concentrated the usage in certain areas, and most of the country it's actually very low demand. So other newcomers, anybody in fact, can now approach Ofcom and apply through Ofcom to share some of the existing spectrum acquired by the operators. for them to use locally without interfering with the operator network. Of course, there are some rules, and it's initially for 3 years. There's a license fee, and it has to have operators agreement. But this is a framework that Ofcom has developed. Now, all these different drivers and enablers, for example, 5G introduced, changes the value of spectrum. So new use cases drives the demand, therefore increase the value of spectrum. Higher data rate, availability of higher data rate, ability to provide higher data rates means users will use more, and that will increase the demand, that will increase again spectrum. The government 5G programs and other technology enhancements, for example, massive MIMO or multiple antenna technologies that can be deployed, particularly in the higher spectrum bands, means that you can now reach further that you couldn't reach in the past. Without this feature, you couldn't reach too far. Only sub 1 gigahertz spectrum, because of the propagation characteristics, could reach could have far high cell ranges. But now the MIMO is enabling this increased cell range, or compensate, in fact, that propagation loss in high frequencies, therefore enabling to reach longer distances. So all those things increase the value of spectrum. And then, as I mentioned, the flexible licensing approach or sharing, those things will, in a way, decrease the value of spectrum from the mobile operator's point of view. Then access to millimeter wave bands perhaps may increase, but because large amount of 3 gigahertz availability of large amount of spectrum will again could decrease the value of spectrum. So when we consider all these factors, the overall impact is actually value of spectrum increases. So this graph shows today's currently identified spectrum for mobile services, and many more is yet to be identified for mobile. So this is just to make the point that abundance of spectrum available may exceed the demand, therefore the value could decrease in many cases. Only USA so far is the only place that the millimeter wave spectrum, 26 gigahertz spectrum, sold above the reserve price, and other countries like Hong Kong, Taiwan, Thailand sold spectrum just above the reserve price. So in summary, I think all I want to say is this additional spectrum provides significant benefits to operators. Because the demand is very high for mobile spectrum, usually they are awarded based on competitive processes. And therefore, it's important to understand the value of spectrum, both from a regulator and operator point of view. Value depends on many factors, including the spectrum portfolio you have today. The awarded cost is a methodology used widely to estimate the value of spectrum. It provides a reliable lower bound. And I think that's probably, I will stop there.